Okay, let's go ahead and get started. Thank you guys for sticking around for the final session of the conference. I imagine that most folks have a lot of ideas swirling around in your head, so I wanted to start off with a lighthearted analogy. And I think it's the presenter's prerogative in order to ask a couple questions right off the bat of the audience. So I have two important questions. How many people have fond memories of the original classic Nintendo? The very first one. Yeah? Okay, and how many people remember the Game Genie attachment for the original Nintendo? Anybody? I got a couple. Yeah, all right, good. Okay, so for those that aren't familiar, the Game Genie was an attachment onto a Nintendo game where you could put it in and then apply a series of codes, and it would modify the way that the games would work. And so you could do things like, for this Ninja Turtle games here that I have attached to the Game Genie, you could give infinite lives or additional powers. You could, start at a different level. Very cool things if you were, 9, 10-year-old kid. And for me, I was just floored by this. To me, this was somewhere between sorcery and just genius. And I was deeply fascinated and really wondered about what foresight the people at Nintendo must have had to create this attachment that worked with every single game that I owned. And it wasn't until many years later that I learned that the Game Genie wasn't actually created by the people at Nintendo. This was done by a third-party company. And in fact, Nintendo adamantly opposed the Game Genie. They thought it was going to jeopardize the success of their relatively new video game console. And so here we go. I'm going to show one of my favorite Game Genie codes. It's a Mario Moonwalk Game Genie code. And I'd played Mario like 1,000 times before I got my Game Genie, and I had seen him run and jump and shoot fireballs, but all of a sudden he could fly. And I mean, this was amazing to me. But after learning, though, that it was developed by a third party, it really made me think about whether this was just some beloved Nintendo accessory, or was it a commercialized hacking device. I have another code up here, or if you put that into a text file and save it as a CSV, open it up in Excel, that it would recursively delete the C drive on a Windows machine. So what is it? Is it a hacking device? Well, Nintendo did everything they could in order to stop the sales of the Game Genie, and there was a series of court battles that went back and forth, and for a while there was a stoppage of sales of the Game Genie in the United States. Meanwhile, individual game makers were also taking steps to thwart Game Genie. They were coming up with memory checksums and other types of security controls in order to stop Game Genie from modifying their game. They thought that people might go to Blockbuster Video, rent the game, beat it really quickly with the help of Game Genie, and then never actually buy their game. There was one game in particular that was really effective at thwarting Game Genie. It was the Bart Simpsons versus Space Mutants game, which was actually a really good game if anybody's played it. They had really effective memory checksums in place, and so it took quite some time for the Game Genie developers in order to come up with codes, but eventually they did it. And at that point in time, Nintendo was really stuck. I mean, this was not an internet-connected device. This was the very first Nintendo, and there wasn't any kind of system for them to roll out patches. And this is, I think in some ways, at least for the security folks and maybe the developers and ops too, we can relate to this. We can't say that we're completely blocked from rolling out security fixes, but maybe sometimes it feels that way. And if you look at the white hat statistic here, on average, it takes a long time to fix critical vulnerabilities. This is a real industry problem, and it's partly why we see so many exploits in the wild. We see them in the headlines. And so what I'm going to talk about is oh, that's not good. Let's see. I'm just going to get a handle on the technical difficulties right away. I think maybe the HDMI is loose, or that work?
What resolution are you at? This happened with the last guy.
Oh, it did? Okay.
It dropped to 720.
Okay. Well, while he's doing that, so what I'm going to do is talk about in architecture to more quickly roll out security mitigations and have security controls in place from the beginning. And so I'm going to talk about cloud-native platforms like Kubernetes and Cloud Foundry, and talk about how you can have a container strategy in order to really effectively patch and upgrade as needed. I'm going to talk about the API gateway and how that prevents against common application level vulnerabilities like OWASP top 10 kinds of vulnerabilities. And I'm going to talk about what's called an IaaS tool, which stands for Interactive Application Security Testing, also known as a container runtime agent, where it's running in the background on the platform, and it's providing real-time continuous security feedback. And so this isn't just vulnerability, third-party dependency kind of feedback. It's feedback about the entire platform. So it's giving you all the details about, do you have Kubernetes configured in a way that is secure? Do you have Docker configured in a way that's secure? And so it's giving all that feedback immediately without the need to kick off tests manually. Also, I'm going to talk about the continuous integration tool and how that helps deploy your applications more quickly. Ultimately, what we're trying to do is deploy secure apps as fast as possible. So to start off, I'll talk about the API management tool and the benefits there and the security controls that you can use. And then I'll detail the 4 aspects of cloud-native architectures, and finally talk about the cloud-native platform itself and the security benefits that you get there. So API management tools generally have, there's a wide variety of them. There's some really lightweight, simple API management tools, and then there's more robust commercial tools. I would group them into 2 parts. You have your pure API management tools, and then you have API security gateways. Some API management tools are really just focused on either monetization or tracking and giving feedback about your APIs. They'll give nice graphs, globe graphs, where you can see where in the world people are calling your APIs. And they'll give you some other security features like authentication and authorization. But for the most part, these aren't real security tools. These are just API management tools. And so if you're looking for an API gateway, be aware of that they're not all geared towards security specifically. But ultimately, both of those types of tools, they're essentially proxies. So they're wrappers around your APIs. And they will let you standardize on a set of reusable API security controls. So if we're talking more about the API gateway, the diagram on the right is a hybrid cloud model where we have an admin console that's running in the cloud, and then it's syncing up to installations of the API gateway that's running in a platform like Kubernetes. You can see that the service wrapper, it's completely independent, which makes it language agnostic. So you could have Python, Java, different types of APIs, and you can still leverage the same API gateway. More specifically, the features include authentication like OAuth, the ability to generate JWTs, and then they support other types of authentication as well. Maybe you have a legacy client that just supports basic auth. And so you can configure a security policy at the API gateway level to verify those credentials as they're coming in. You also get application level security policies, and in more of the robust, sophisticated API gateways, you get some of these right out of the box. There's been a number of good OWASP top 10 type presentations at this conference, and they've talked about cross-site scripting and path traversal and open redirects. In a lot of cases, you get those types of mitigations for free. So I will say that generally, the API gateway is well received by developers and operations folks. But I think what's pretty common is the perception of security folks, they're coming up with excessive or really just superfluous requirements. And people are just naturally inclined at this point in time to sort of push back and reject these ideas from a security group. Like no matter what you're doing, it's just not quite good enough, or just like a ridiculous password policy requirement. And I will say that the API gateway, it's a rare win-win between developers and security. And partly it's because the gateway, it's not a complex integration. You could take an API that you never even thought about using the gateway with and wrap it. How often do you have a security control that actually reduces the amount of code that a developer has to write? And how often do you have a security control that speeds up and increases the time to production? So that's what's different about the API gateway. And I think about this in terms of boilerplate code. And that's the code that developers will write from app to app. And it's very similar. They may have to make just slight adjustments because of the framework or the language that's in use. That boilerplate code really goes away when you're using an API gateway, at least some of it, especially the security-related boilerplate code, because you can extract it and put it into the API gateway and then reuse it over and over again. I like this definition here from Wikipedia about boilerplate code, especially the last part where it says the need for boilerplate can be reduced through high-level mechanisms. The API gateway is that high-level mechanism. So let's take a look at a real example of how an API gateway could help mitigate an application vulnerability. Like I said, that there's been a lot of great presentations about the most common types of vulnerabilities, like the OWASP Top 10. I'm going to look at one that's a little bit lesser known. And this is that same CSV formula injection example that I mentioned a minute ago. Hopefully this video is going to play. You can see that I have the CSV file there, and it has that command, equals command with an rmdir, and then a directory. I'm opening up that file and accepting the warning that Excel gives, and you can see that that directory just magically disappeared. That's CSV formula injection. So how would you mitigate that at the API gateway level? If you had an API that was returning CSV, you could write a policy that's going to look for formulas, which is any common delimited cell value where the first character is not just equal, but there's some other ones as well. You could parse the response, and then you have a decision to make. You could either send back an error or an exception, or you could actually modify the actual response and return that. And so that may not be the most common type of vulnerability, but I thought it was an interesting exploit example. Is the API gateway going to fix all your application security problems? No, it won't. And the prominent author Gary McGraw, who used to be the COO or CTO of Cigital, he wrote about the myth of perimeter level security, and that's what an API gateway is. It is perimeter level security. It's much like an intrusion protection system, or it's really a specialized web application firewall. It's not going to fix all of your problems by any means, but it's one part of the solution. It can provide authentication, especially like OAuth or even verifying client certificates. It can handle those things for you. So practically, how do we actually use the API gateway? We've been doing it for a couple of years now at SAS. And usually we choose one authentication type of policy. We'll choose OAuth. We've also integrated the API gateway with our identity provider, our identity management solution. And so we have a policy that we can use for that. And then in some cases, we will use basic auth or client certificates. So you choose one authentication policy, and then there's another set of policies that we always use: rate limiting, throttling, basic types of validations for obviously malicious requests, like obvious cross-site scripting attempts. We'll block that at the API gateway level for every single API. And then other things like cross-site request forgery as well. And then we have these other policies, like CSV formula injection, that are kind of in our back pocket. Imagine if you have an application that's ready to go live. You get a pen test report back. There's a bunch of vulnerabilities. It's nice to be able to say, hey, this is an API gateway wrapped API, and so we can just use this policy. We can easily apply it and then mitigate that. Now, maybe that's a short-term fix or the full-fledged fix. It really depends on the situation, but it's nice instead of having to say, you guys need to delay your production go live, we can say, hey, use this policy, and then you guys are good to go. It's nice to have that. On the left there, that is the OWASP Top 10. That's actually the 2013 list of it. But you can see that the API gateway is helpful for many of those items. But we're going to talk about the cloud native platform next and how that helps the security posture of this architecture as well. These are the 4 aspects of a cloud native architecture, and you can see that the platform is there behind it. We talked about the API gateway as it relates to microservices already. I'm going to get into DevOps and DevSecOps next, and then talk about the role of the continuous integration system and then how that helps with upgrades and patching, and also how the containers and choosing base images and in Cloud Foundry choosing your build packs wisely, how that really helps with an effective upgrade strategy. So the first is DevOps and DevSecOps. My definition is that DevOps empowers developers to perform operations and also security tasks themselves, but with guardrails. So we're not fully turning over the reins. We're not fully saying developers just do everything yourself. I still believe in the separation of concerns. And so I think that it makes sense to, specialization of labor where you have experts in each field. But there are certain tasks that developers should be able to do themselves that in the past, in a traditional architecture, they couldn't. A part of the reason that DevSecOps is possible is because of the cloud-native platforms have such robust handling around infrastructure as code. You can specify most of the metadata, almost all of the metadata around an application in the YAML files or the JSON files for both Kubernetes and Cloud Foundry. And so developers can modify those files, include them in their code base, and then make changes as necessary, where they're then deployed with a button push click inside your continuous integration tool. So that's infrastructure as code, and sometimes I refer to this as security as code as well, because you're putting some of the security controls right there in the code base as well, at least the configuration aspect of it. So the platform's allowing developers to do things which typically in the past they had to open up tickets for. And that's a part of the friction that DevOps is trying to eliminate. DevOps is a way to help developer and operations and security folks better collaborate with one another. Operations folks in the past would get bogged down with endless queues of tickets, and then developers would get frustrated because they would be waiting for operational folks to implement those. I mean, it was not a good situation on either side. But now, with infrastructure as code, developers can do those kinds of things themselves, like basic things, setting environment variables, scaling the app, just increasing the amount of memory, saying I want 5 load-balanced instances of this application. You can do all of those things really easily with the configurations in Kubernetes and Cloud Foundry. Developer can also do security tasks. They can set security headers. There's ways to integrate the tools with your password vault. And then even things like forcing SSL for the app. Those are all things developers can do themselves now with configuration as code. So to give an example of that, on the right I have a Cloud Foundry manifest file. You can see where I've set the memory amount, I've set the number of instances, we're forcing HTTPS. A developer can change the URL whenever they want. And on the left, I have an example of an Nginx comp file. In the Cloud Foundry world, they have what's known as a static build pack, which is really just a type of image. And it's Nginx based. And so developers can set these files, put them in their code base, and then change the response headers as needed. For many teams in the past, it was the operations team that exclusively maintained configurations for things like an Apache server, and that's where this would be done. So you would have a ticket to the operations team in order to change those kinds of headers, but again, developers can now do that themselves. The content security policy, that's especially valuable for mitigating cross-site scripting, and it is an example of one of those configurations that does seem to change on a regular basis. So it actually makes sense for developers to be able to do that security task themselves. Now the next thing I want to talk about is the IaaS tool in greater detail. That stands for Interactive Application Security Testing. Sometimes it's called a Container Runtime Security Agent. And remember that these cloud-native platforms are distributed and they're multi-tenant. And so you have applications running side by side on the same worker nodes. Similarly, the IaaS tools or this agent is running on, it's running on each one of those nodes. And so in a Kubernetes environment, this is a daemon set. And by running all across the platform, it's able to report continuously. Everything from application level vulnerabilities as far as third-party dependencies goes, but also compliance issues like, is the container running as root? Does it have access to the file system? Does it have write access? Can it access host resources? Can it access like the host network, for example, which would be a big security red flag? The IaaS tool is going to report on all of those things and give that feedback. Pod security policies, especially for Kubernetes, are so important, and also the security context as well. That's another thing that the IaaS tool is looking at. But it also provides things like malware protection. Now you may think, at least our experience was, we have these tools, we've used them for a long time, so it provides malware protection, file integrity monitoring, and their websites for those tools advertise that they support and work great in containerized environments. But then after you really dig into it, you find that it's pretty difficult to take those traditional security tools and make them work with containers. And so having a cloud-native security testing tool is hugely important. And that's what these container runtime agents are. The other thing that they provide is detailed audit logging. So if you're running in a regulated or highly compliant environment, then that's absolutely essential. Now, the thing about these tools that are running continuously is that you need somebody to actually look at the results. And so this is why it's so important to have a network of security champions. Having a group that has been educated about how to use the tools, understand the findings, triage the results, mark items as false positives, that's so important. Otherwise, if the tool's reporting these findings and nobody does anything with it, then, then what's the point? So the security champions is absolutely crucial. Next, I want to talk about containers and how that impacts patch management. So with microservice-based architectures, you end up with a lot of applications. And so you need a way to upgrade those applications. And both for Kubernetes and Cloud Foundry, if you're strategic in the way that you whitelist those allowed images, then you're going to be in much better shape. Cloud Foundry sort of does this out of the box with their system of build packs. Cloud Foundry and the people at Pivotal release build packs for each major language. So there's one for Java, .NET, Python, and so on. And every time that there's a security vulnerability, which gets published as a CVE, every time that comes out, the folks at Cloud Foundry and the open source community is going to upgrade the build pack and then release that new version. And so, your company and what we do is we at times customize those build packs, and then we push them out to our different running environments. And the great thing about build packs is that they come as an ordered list. So you can have multiple Java build packs, let's say, put the latest and greatest there at the top. And so next time an application goes to push out a version, Cloud Foundry will detect that it's a Java app, use the latest Java build pack, and automatically, you've gotten the updates that way. And the thing that I really like is that in the event of a critical vulnerability, it's possible to roll out that build pack to all of the applications at once. So let's say that you have 100 Java applications. You can do a clean swap of that layer underneath and force those apps to restage and get the latest build pack. And I'm also going to talk about misconfigurations and about how whitelisting images can help avoid misconfigurations. So I want to compare Docker's images versus Cloud Foundry build packs for a minute. There's a real risk with Docker images of just sprawling out of control. there's Docker registries, various available. I think the first step that you can do in terms of having a good patch management upgrade process is to whitelist a set of images. And that can be just, at a bare minimum saying, only use the official Docker repositories, only use those official ones that are blessed by Docker. That's a great starting point. But what we found is that for containerized microservices, you typically don't need a full-fledged OS. You don't really need a full CentOS or a RHEL. And that there are lightweight base images like Alpine, which is a lightweight Linux distro. You can use those kinds of images, which are significantly smaller and reduces the security footprint. So that means that they're faster, they use less disk space. And once you start doing continuous security testing, you'll see that over time, there's way fewer issues with these lightweight, slim images like Alpine compared to the full-fledged OS versions. Like this Tomcat Alpine Docker image is 15% the size, and it's so much smaller, and the security footprint is so much smaller. It's a big win all around, really. So if you can't have a fine-grained whitelist, of your images, at least like encouraging Alpine is a good step forward, or another slim distribution. There's Alpine images, by the way, for Nginx and Java, OpenJDK, Python, and the list goes on. The other big win, oh man, I'll go back here because it likes this slide better. The other big win with whitelisting a set of images is that you avoid misconfigurations. So in a traditional environment, especially before Ansible and Puppet and technologies like that, every environment was built custom with a lot of manual work. And as a result, there was a great potential for human error. For example, somebody may leave the Tomcat administrative console completely open and using default credentials. Those are the kind of exploits that you hear about in the wild in real environments. And so by whitelisting a base set of images, like using the Tomcat Alpine Docker image, those types of things are disabled by default. It's secure by default. And by minimizing the amount of customization to your Docker images, you're less likely to have these kinds of misconfiguration issues that, like I said, cause real issues. All right, next up is continuous integration. And I imagine that people in the room have been using continuous integration tools for a long time. Who's been using CI for more than 5 years? Anybody? Anybody more than 10? I think it was about 10 years ago when I first started using continuous integration tools. They've been around a while. So why is this a core part of cloud-native architectures? I think what's special about cloud-native is that they have very robust APIs and CLIs. So you can go from 0 to full production app just with the configuration metadata files. There may be just a slight bit of initial setup on the platform itself, but the application it can be fully automated. And so that means what you're doing with your application in terms of your CI setup is much different. And I'm going to show in the next slide here, but you're doing things like pulling your secrets from your secure vault, pushing out the app, binding it with any dependencies that it needs to a database, for example, running your CI tools automatically. I mean, you can do a lot more with the cloud platform than you could in the past, like with a traditional Jetty or Tomcat, where really the best you could do is just push out a new version of the application. Now you can fully tear down and then redeploy. So this is what that looks like. Think of your continuous integration tool as going out to your source code repository, pulling the source code, and then it's running the static analysis tool. And by the way, you might be thinking, well, why aren't we using the IaaS tool? And so, full disclosure, a lot of the IaaS tools are super expensive. I mean, you heard me describe how great they are and how they reduce manual efforts. And so, as you would probably expect, they cost a lot of money. And right now, the IaaS tools are relatively new in the market. We compared several of them and found that those IaaS tools oftentimes don't do everything. They don't do static analysis, source composition analysis, and dynamic, unless you're willing to write a really big check. And so you might still be doing security testing through your CI pipeline, or maybe for extra verification, you want to do that. Maybe you want to fail a build, for example, if there's a high severity finding. So after the CI tool runs the static code analysis, it's going to grab the artifacts. Maybe you're using something like Nexus or Artifactory, and then it's doing the composition analysis. That's the SCA. That's the third-party vulnerability checking. And then it's going to programmatically reach out to your password vault, push the application, and then the final step is to bind that secret to the running application. And I'm going to talk about secret scoping and segmentation in a minute, but the idea here is that you are really limiting who can access that secret by binding it just to the application, or in the case of Kubernetes, it's available through other apps that are running in the same namespace. Okay, so microservices, last but not least of the 4 aspects I'm going to talk about. A lot of times people will find microservices by what they're not. They're not monoliths. Microservices are independently deployable. You might have 10 microservices that are 10,000 lines of code instead of one big 100,000 plus line application. And I think most groups have been doing microservices long enough where we've seen the pros and cons of this approach. Let's say that you have a security vulnerability with your monolith. It can be like this 18-wheeler here. It can be really difficult in order to make a quick change. A lot of times with monoliths, there's tight coupling, and as a result, you have to do a pretty big set of regression testing. And so it might take 3 months or 6 months in order to get that fix out to your production environment. Now with microservices, because they're independent and they're independently deployable, it's likely that you can get those fixes out more quickly if it's just the one microservice that you need to update. There's pros and cons here. And we've already talked about the build pack or image strategy needed to help with the upgrade aspect. But what about application level security controls? And I'm going to use the example of CORS headers here. And And you can see the diagram there, or the picture on the right. They're juggling all these balls, which is just like juggling lots of microservices. And hopefully you can see the one on the left where they've dropped the one ball there. I mean, it's easy. There's complexity in managing lots of things. So let's look at an example with cores. So let's say that you have a monolith, and it has some API endpoints. And those API endpoints are being called from a browser from an application that's hosted from a different domain. Now, the API is going to have to return cores headers because the browser, all modern browsers, enforce what's called the same origin policy. If it sees something from evil.com, it's going to require some cores headers coming back from the API to say that it's OK for evil.com to call your API. Now, if you're implementing this, you're a developer, the quickest and easiest thing you can do as far as setting your cores HTTP response headers is just set this star here in the gray. Just set it to star. Say, everybody can call my API. It's OK. The monolith goes through penetration testing, and the pen tester says, the cores headers, they're overly permissive. This is not good. This needs to be fixed. And so the monolith developers, they're like, cool, we can fix this. We can create a whitelist, no problem, done. And so you have some custom cores header, custom cores code that's within the application. A few months later, monolith B comes along. Same thing, but this time they're savvy. They know about cores. They know about the security risks. And as a result, they think, we're going to modularize. We're going to create a component. And this is going to be elegant and reusable. And so they make some bug fixes, and they end up with a cores filter at version 1.1. 6 months later, monolith C comes out. There was another security pen test. They realized that there were a couple of bugs. Maybe there was some functional bugs as well. And they end up with version 1.3. So what do we have here? We have really a security control. And they now have 3 implementations of it. So ideally, you would be able just to take the one very good implementation, the one that's most thorough and most secure, and apply it to all of your applications. And that really brings us full circle back to the API gateway. That cores code, that is your boilerplate. And you want to extract that into the gateway, especially as you have lots and lots of microservices, so you can reuse the very good implementation, the one that's very thorough. So let's get into the cloud-native platform. Sorry about the slides there. So like I said, the cloud platforms, they are distributed. They are multi-tenant. And so you have disparate applications that are running side by side in the same node. This is not separate VMs. We're talking the same instances, right? And so you have to leverage certain features within the cloud-native platform in order to keep those apps safe and secure. And so there's 3 types of segmentation. There is microsegmentation, network microsegmentation, resource segmentation, and also secret segmentation or secret scoping. You need to leverage all 3 of those things in order to protect your APIs. Imagine if you have one application that's running and there's a memory leak, or maybe there's an active exploit going on and it's sucking up all the memory there. You need that resource segmentation. You need to be able to define resource limits. You need to be able to define those resource limits, and so that one misbehaving app isn't going to suck up all the memory. Similarly, we need microsegmentation into place. Oftentimes with these cloud platforms, they're sharing IP addresses. And so you have multiple apps that are being served up from the same IP address. And so your conventional approach to firewalls and firewall handling may not work, depending on the type of firewall that you have. And so the platforms have network microsegmentation built into them. In Cloud Foundry, it's called ASGs, or Application Security Groups. In Kubernetes, it's called network policies. All right, and I'm going to talk about the orchestration engine as well and how that offers protections against denial of service protection. The orchestration engines are constantly evaluating your running applications and how many instances or replicas you've requested. So maybe you requested 3 instances, and that's the desired. It's going to constantly, the platform's constantly checking the actual number, and it's going to try to reconcile any differences between the 2. So in the event that an application actually falls over one of those instances, it runs out of memory or there's some kind of issue with it, it's just going to spawn up another one. And the platforms do that within seconds, microseconds. It's very fast. Okay, So in a second, I'm going to show a more zoomed-in view of the cloud-native platform. I'm going to show two different APIs that are running in separate Kubernetes namespaces. And we're using the segmentation features built in. So imagine that you have one of the APIs that's trying to make an external call to a database. You're going to whitelist that with your Kubernetes network policy to actually call out that it's allowed for that connection to occur. But that application doesn't need to get to any other databases. It doesn't need to make any other outbound connections. And so why should it be allowed to? So now imagine that you have another API, and somehow it has malware that's successfully running on it. So there was a file uploaded, the malware is running, and what that malware is trying to do is data exfiltration. It's actually trying to steal data that API or maybe the file system, and it's trying to send that out to evil.com or some other site. If you have network segmentation in place, then those kinds of outbound connections to some random website is going to be blocked by default. Similarly, for resource segmentation, you're going to allocate a set of memory and other resources both to the segments and the individual APIs. And by doing that, you're going to make sure that one of those isn't going to suck up all the resources and cause system degradation on some API that's running on the exact same worker node of the platform. And so lastly, I'll talk about the third type of segmentation, which is secret segmentation. Really, I think more commonly it's referred to secret scoping. And so with the namespaces in Kubernetes, and Cloud Foundry has something similar, when you create a secret, it's only accessible by applications in the same namespace. So other apps aren't able to access that secret, and that prevents a breach. So if you imagine like a traditional system, there we go, that's on the left, where you have lots of applications that are running on the shared server, without the segmentation features, there's more risks that those applications could get to one of those secrets. So using namespaces, strategically is a great way really to limit what can happen in a worst case type of breach. These network segmentation, resource segmentation, that's really going to save your bacon in the event that you have malware or some other exploit actually happening. It's going to minimize the scope and potential of what that breach can do. And so the last one I'm going to talk about is the orchestration itself. There is a common, this is an OWASP top 10 vulnerability called XML entity expansion. And down here I have an XML snippet, which is known as the billion laughs attack. So if you send this XML into an XML parser, it's going to continuously expand these entities to the point where a typical application is going to run out of memory and it's going to crash. But because the orchestration engine is constantly scanning and looking at the desired state versus the actual state, let's say that you have 3 replicas, it's going to detect if one falls over. I have tested this. It's one of the fun parts of my job. I tested this on actually Cloud Foundry, and there was no downtime whatsoever. Instances were falling over, but they were immediately being respawned back up. And so this is sort of, you get this kind of protection for free because of the constant health checking and the respawning. All right. So to summarize, we've talked about the API gateway and how that can mitigate common application level security vulnerabilities. We've talked about the segmentation features and how that's so important when you have a multi-tenant distributed platform. Talked about the IaaS tools, and if your company can afford it, how that just streamlines security testing and gives you that continuous feedback. What we're getting at here is to get fast feedback to the developers so they know about the security of their applications. To me, that's a big part of DevSecOps. And ultimately, we want to help developers quickly deploy secure, production-ready applications. So I wanted to finish up with just a few thoughts about DevSecOps. Originally, it's been a couple years now, we defined a network of security champions. And I think that's absolutely essential if you're aspiring, moving towards DevSecOps. You need a network for communication. And part of that is because security groups are often very much outnumbered. right? You have small security and compliance teams and lots of developers and operations folks at a typical company. And so having this network of security champions is so important so you can get out application security initiatives like using an API gateway or like network segmentation. You need that for communication purposes. But I will tell you that when I initially formed that group, I sort of imagined that it would be a lot of, the security folks telling other people about how to secure their applications. And I really realize now that that was hubris on my part. What's turned out is that it's enabled relationship building and two-way communication and understanding the problems of other groups. And so my advice for folks, if you're moving towards DevOps, is talk to people and listen and try to search for mutually beneficial solutions. Think of this as searching for the win-win. I mentioned with the API gateway that it's beneficial for developers because it reduces boilerplate code, and you get these high-quality, reusable security controls. That's a partnership. That's a joint victory in a way. Similarly, look to partner with operations, understand their concerns, which is, hey, this new architecture moving towards cloud native, am I going to start getting called all the time in the middle of the night? Are there going to be outages? And admittedly, there is definitely a learning curve with moving towards cloud native. It takes time and education and going to conferences like this to learn about it, I think. But in many ways, this is moving towards this platform. It has simplified life for the operations folks, in part because of the health checking and the respawning. That helps with both availability for them so that they don't get called in the middle of the night. And it's also great for security because we're protected sort of inherently against different types of security attacks. And lastly, the IaaS tool. And also, using security tools that work well with the CI pipeline. I think that's so important. There's a lot of variance in terms of who runs security testing tools at various companies, but whoever's running them, make it as easy as possible on them. If you think that you can do something in the name of security, this is the right thing to do for security, and so of course we're going to do it. That's a big mistake. It's really about searching for these mutually beneficial solutions. And I think by listening and actually trying to better collaborate, which is what DevOps is all about, you end up with better solutions and processes as well in the end. And that is about it. And I think we have a couple minutes. If anybody has a question, I'll try to answer. Yep.
Yeah, I had a question. I know they're expensive, but are there particular vendors for IaaS that you think would be worth a look?
Yeah, and if you want to talk to me afterwards, we looked at a lot of different solutions, and so I can give you my thoughts about that.
Okay, I have another question.
Okay.
So have you done any testing with like AWS's API gateway and looked at sort of its capabilities, slotting it to what you were describing here?
Yeah, and so it's been a while, but we did a comparison of multiple API gateways. My understanding, we didn't actually look at Amazon's at the time. My understanding that Amazon has a WAF, Web Application Firewall, and that their API gateway doesn't, provide that same kind of security functionality. So it might be a combination of those two, but I'm speaking outside my knowledge now, so I'm going to stop. Any other questions?
Can you talk about how APIs onboard to your API gateway? Is it all self-service?
And that's been something we've been working towards for sure. Automation actually is a part of what we consider infrastructure is code, or security is code. We have a system where folks can create JSON files. So it exists as a part of your code base. We have a continuous integration system where that's an artifact. And then when we go to deploy the APIs, it automatically applies that JSON file. So this works really well in Cloud Foundry. The Cloud Foundry mechanism for hooking up a proxy, which is essentially what the API gateway is, it's called a route service, Cloud Foundry route service. And so you can programmatically configure the API gateway. So the parts that are manual, though, And this is more of like a conversation between development and security. It's about what security policies make sense. So like I said, you're choosing one authentication option, and then you're always using some of these other policies. That's the part that takes some time. Applying and some API gateways allow you to simply drag and drop the policies you want, or they provide an API or CLI to apply whatever policies. But it's really like the decision process is what takes time. All right, any other questions? Okay, well, thanks very much, everybody, for sticking around.